So a week ago, I filled these test pieces with 60 ml of water to see how infill percentage affects their porosity, and we have some results. So surprisingly, these results show effectively the opposite of what you'd intuitively think. That being that adding more infill makes it more difficult for water to travel through a part. However, I actually found that the opposite was true. The 60% infill test piece performed the worst, losing 65% of the water in the central cavity, with 15% remaining in the walls of the part and the rest leaking through into the drip tray. The 30% infill test piece fared a lot better, only losing about 40% of the water from its central cavity, most of which was absorbed into the part with a minor amount of evaporation. And finally, the 15% test piece performed well with no leaking and only 20% of the water being absorbed into the print. So what do we think is going on here? Now, this is all mostly speculative, but I think that every time an infill layer is printed and connects to a previously printed wall loop, it causes rapid heating and cooling of the layers at the point of connection. This would result in a rapid thermal expansion and contraction of these layers, likely resulting in tiny thermal stress fractures and delaminations, allowing easier ingress and egress of fluid. Again, this is just a bit of speculation, and I'd love to definitively prove this at some point in the near future. And as a reminder, these results aren't 100% accurate, as my scale just isn't very good, but the trend noticed is still valid. I'll be creating a longer format video to go over the results in detail, so keep an eye out for that if you're interested. In the meantime, however, I'm going to be repeating this experiment, but instead of infill percentage being varied, it's going to be wall loops. Let me know your thoughts in the comments. Cheers for watching, and I'll catch you next time.